In this paper, we present ArtiGrasp, the first method to synthesis dynamic bimanual dexterous grasping and articulation in a physically plausible way. We manipulate complex objects every day. For example, we operate a coffee machine, open a laptop, or pass a box to another person. The ability to model such interactions is crucial for animation, human-computer interaction, and robotics. Capturing detailed human motion in films and games is costly and challenging due to extensive data cleaning. A model that can generate two-handed object interactions could considerably reduce these costs. Based on this overall goal, we introduce a task, dynamic object grasping and articulation, which combines grasping, relocation, and articulation with two hands. In this task, we are given two pairs of hand pose references, an initial object pose, and a target articulated object pose. Our aim is to generate two-handed motions that bring the object into the target articulated pose. First, the object has to be grasped firmly. Then, the object has to be relocated to the global 6D target pose. Finally, the object has to be articulated to reach a target articulation angle. We now present our method ArtiGrasp. We formulate the task as a reinforcement learning problem and use a physics simulation. We propose a general framework which can handle the grasping and articulation of many different objects with unseen pose references. We train a unified policy for each hand which can handle both grasping and articulation. The state of an agent consists of the poses of the hand and object, as well as contact information. The policy network takes as input the physical state and a hand pose reference and predicts actions to control the hand in simulation. We define two rewards, an imitation reward that compares the agent's grasping pose to the hand pose reference. A task reward measures the distance of the articulated object pose in the simulation to the target. One of the challenges in this task is the precise finger control needed for successful two-hand manipulation and object articulation. To address this, we introduce a learning curriculum by first training our policies with a fixed object base and in separate physics environments. Then we use a non-fixed object base during manipulation, and let the hands interact in a shared physics environment. Now we present our experiments. We use the recently released Arctic dataset for our experiments. It contains accurate 3D ground truth annotations for two-hand manipulation of articulated objects. It includes objects with 1 degree of freedom for object articulation. Here we show results of motion synthesis for different objects using our method. We compare DGrasp on the left with ours on the right. This demonstrates that ArtiGrasp outperforms DGrasp for the dynamic object grasping and articulation task. This is also reflected in the quantitative evaluation. See our paper for more details. Here we compare existing methods and ours in grasping-only scenarios. We also compare them in articulation-only scenarios. ArtiGrasp has similar performance to DGrasp in grasping on the unseen test set. Yet, it performs significantly better in articulation. Here we show more results of our method for grasping and relocation. Here are results for articulation. We show that our method can generate motions with unseen hand reference poses reconstructed from single images using an off-the-shelf method. And different targets can be defined. Our policy shows some recovering behavior from failure cases. For example, when the agent fails to grasp the object, it will keep trying until it finds a good grasping pose, and finally articulates the object successfully. This indicates the robustness of our method. However, the generated motion can have unnatural finger joint rotations. This is because our method trades off the task objective with the imitation objective, and the hand pose reference can sometimes be noisy. In summary, we present ArtiGrasp, a novel method to achieve bimanual manipulation. It's a general framework that can train a single policy for both grasping and articulation of different objects. We devise a learning curriculum with increasing difficulty to handle the complex control that is necessary for articulation and bimanual manipulation. For evaluation, we introduce a new task: dynamic object grasping and articulation, and show that our method can successfully tackle this task. We show that our approach can use unseen hand pose estimates from a single image to generate dynamic grasping and articulation.